We're now going to take a look at converting hexadecimal values into decimal values. Now, we first need to understand the 4-bit setup of a hexadecimal value. Basically, with our value on the most right being 16 to the power of 0, which is equal to 1. Then the next bit being 16 to the power of 1, which is equal to 16. Then 16 to the power of 2, which is equal to 256. Then 16 to the power of 3, which is equal to 4096. So the first value we're going to look at is actually the value of A. Now, we could have done 1 as our first value, but 1 is basically equal to 1 in decimal as well. But A is a bit different because A actually represents the value of 10. So A, being a digit on its own, would go on the most right. So A is equal to 10, okay, which then equals 10 times 1, which is equal to 10 in decimal. Okay, so that was an easy one to start off with, provided we know that A equals 10. The next value we'll look at is 2b, kind of like the pencil that you use, 2b. So once again, we'll put it under the correct brackets it belongs in. Now, 2 is equal to 2, and b is equal to 11 in hexadecimal. So this translates to 2 times 16, 11 times 1, which then becomes 32 plus 11, which equals 43 in decimal. The next value we'll look at is 1CD. Okay, so we'll put that into our table. 1 is obviously equal to 1, C is equal to 12, and D is equal to 13. So we'll build upon this. 1 times 256 plus 12 times 16 plus 13 times 1, which is equal to 256 plus 192 plus 13, which equals 461 in decimal. A larger character that makes up of all 4 bits of the hexadecimal set is 22EF. So we'll put this into our table. So 2 times 4096, 2 times 256, E stands for 14 times 16, and F stands for 15. So we'll put this into our brackets, and as you can see, our equations are getting quite long and complex now, and this becomes 8,192 plus 512 plus 224 plus 15, which is equal to 8,943. Okay, so that's an example of a large hexadecimal value. The last value we're going to look at is actually our maximum 4-bit hexadecimal value, which is actually FFFF. And F, obviously, as mentioned before, translates to 15. So basically, 15 is going under each one of our brackets. So this translates to 15 times 4,096, 15 times 256, 15 times 16, and 15 times 1. This equals 61,440 plus 3,840 plus 240 plus 15, which then equals 65,535. Now, this gives us a sign that no hexadecimal value or 4-bit value can be bigger than that value there. The next value that is 1 bit above it is obviously 65,536. And that happens to equal what 16 to the power of 4 equals. So I hope you understand that relationship of base 16 growing and knowing what our values are equal to. So I hope this video has given you an understanding of hexadecimal to decimal conversions, in that basically once again we have kind of a 4-bit setup on a table, and we need to know what 16 to the power of 0, 16 to the power of 1, 16 to the power of 2, and 16 to the power of 3 are all equal to, and then we basically times those values by the digit and where it sits in the 4-bit hexadecimal number.